The video you're watching right now isn't just edited with subtitles. It's actually generated by a new class of models from a recent paper by NVIDIA and MIT called StreamingVLM. StreamingVLM represents a huge leap toward real-time, human-like intelligence, a model that can watch infinite video, reason continuously, and respond instantly. But how does that even work? How can an AI understand a never-ending stream of video without crashing or forgetting? Let's break it down. So, how does StreamingVLM actually work? At its core, it's a unified framework that finally aligns how a model is trained with how it thinks during streaming. Here's the idea. Step 1. During training, the model watches short, overlapping chunks of video, using full attention. This helps it learn smooth transitions, how one moment flows naturally into the next, without getting confused when clips change. Step 2. At inference, that's when the model is running live, it switches to a sliding window setup with something called an attention sink. That lets it handle infinite video streams efficiently, just like watching a live broadcast, while staying aligned with how it was trained. Step 3. The model reuses its past memory, those key value states, and uses continuous position IDs so it never loses track of time or context. The result? A stable, smooth, and fast system. Now, to make this work, the team built two massive datasets. First, InfStream's a huge sports commentary dataset with over 4,000 hours of video. Then, InfStream's eval, a benchmark built for ultra-long videos, averaging more than 2 hours each, testing whether the model can stay coherent every single second. Using these datasets, the researchers fine-tuned Qwen 2.5 VL7B Instruct, creating the final model, StreamingVLM, capable of real-time video understanding and live commentary. And the results? Pretty impressive. It does all of this while keeping latency low and performance stable. That makes StreamingVLM ready for real-world use, from live streaming and sports analysis to autonomous systems that can see and reason in real time. Here's a figure on the screen, comparing different attention methods. Full attention connects every frame to every other one. Powerful, but heavy on cost and memory. Sliding window without overlap saves memory, but forgets context, losing track of what just happened. Sliding window with overlap remembers a bit more, but recomputes attention every time. Inefficient. StreamingVLM reuses past KV states, keeping short visual and long text windows active. Smooth, continuous reasoning with low latency. Let's look at the challenges with current visual language models. Without fine-tuning, they can't keep track of long-term context. Full attention is powerful, but memory and latency explode after just a few minutes. Sliding windows save computation, but lose important context. StreamingVLM solves this. It generates coherent, real-time commentary while remembering long-term history. The secret is a streaming-aware KV cache. It reuses past states for text and vision tokens, evicting old frames smartly to reduce computation while keeping enough context for smooth reasoning. Positional drift is handled with contiguous rope. When old tokens are removed, new tokens' positions shift to stay continuous, keeping both vision and text aligned even over long videos. The result is a model that can watch hours of video, retain context, and generate continuous, coherent commentary. To teach StreamingVLM how to handle streaming video, the researchers used a clever training strategy. During training, long videos are split into overlapping chunks. Each chunk contains both vision and text tokens interleaved at 1-second intervals. The model applies full attention within a chunk, meaning every token can see all other tokens in the same segment. This overlapped full attention training mirrors the inference time setup, with attention sinks, a longer window for recent text, and a shorter window for recent vision stored in the KV cache. By aligning training with test time context, the model learns the right recency bias, producing stable streaming behavior without needing prohibitively long video clips during training. Importantly, vision and text tokens are interleaved rather than grouped separately. This teaches StreamingVLM exactly when to speak and when to remain silent, resulting in reliable, real-time commentary that stays synchronized with the video stream. StreamingVLM's dataset comes from over 2,400 sports games with English commentary. WhisperX extracts speech, then GPT-5 cleans it, keeping, editing, or deleting sentences to match video content. The result is high-quality, time-stamped video commentary pairs, perfect for training the model to generate real-time, coherent commentary. For benchmarking, captioning is evaluated on InfStream's eval with 2-hour videos and live sports 3K/cc. Video understanding uses Video MME, MV Bench, Long Video Bench, and OVO Bench, covering short clips, long videos, QA, actions, and real-time perception. Results show StreamingVLM surpasses all baselines in both captioning and VQA tasks. It delivers stable, coherent commentary over long videos and consistent gains on long-horizon real-time reasoning, proving the streaming SFT pipeline effectively boosts both understanding and generation. And that's a look at StreamingVLM.
StreamingVLM, real-time understanding for infinite video streams. Warriors bring up the ball. Green at the top of the key, dribbles right, passes to Livingston. Livingston looks inside, finds Green on the wing. Thompson drives baseline, kicks it out. Ball back to Green. That is a good pass. The ball comes back to Green. Green drives in, pass to Iguodala, looks for a screen, takes it himself. Step back jumper, he missed. Quick pass to the corner. Thompson open. 3, no. 93-92. Green pushes the pace. Rockets secure the ball. Harden slows it down, setting up the offense. Secure the ball. Watch this move here. He goes to the left hand at first. Then he comes around to the right. That's awfully difficult to defend. 2 minutes remaining in the opening period. In tight, off the glove of Lack, Truba. A bouncing puck couldn't pull the trigger. Jets get caught for a split second, and Perot had the wide open net if he could have chipped it in. In front for Enstrom. Scores. 1:47 left in the first. A solo shot from Kevin Kiermaier. David Phelps worked a scoreless fifth, allowing a hit but no runs. And Forsythe strikes out. 8 pitches, 6 strikes, 3 up, 3 down.
Hope you enjoyed the video. Don't forget to like and subscribe, and we'll see you in the next one.